So for a question like this, we have some givens, which is the height, which is 3.5 meters, and we're also given the angle, which is 40 degrees. And so what we need to do is we need to find the velocity in which the dolphin sort of launches itself. So let's say the dolphin looks a little, so the angle that the dolphin's launching itself is at 40 degrees, and obviously it's going to have its horizontal velocity and the initial velocity. And what we actually need to find is we need to find this, the initial velocity. So we have the initial in the y direction and the initial in the x direction, but we need to find the resultant, which is this. So we need to find with the angle what velocity is the dolphin launching itself in order to sort of get through that loop. We need to figure out the minimum velocity. And so to do that, we need to write VI, so the resultant velocity, which is the initial resultant velocity, with this 40 degrees. So how are we going to do that? Well, just simply use sine. So we have sine 40. The opposite is the initial velocity, the vertical initial velocity, divided by the hypotenuse, which is the resultant. And what we'll do is we'll multiply by VI on both sides, crossing it out and bringing it on this side. So we're basically isolating for this, but we don't really need to figure the velocity, the vertical initial velocity out. It's equal to sine 40. There you go. And so another reason why we actually need to write it in terms of this, the initial vertical velocity, is as we use the energy laws of conservation, as we use mg change in y, when we use this, that only means vertical, so up or down. And so that's why we need to write it in terms, you write the velocity in terms of the vertical component. So let's actually use energy conservation in order to help solve this. So we know the two energies in this would be gravitational and kinetic. That's equal to 0. The gravitational energy, does it increase or decrease? Well, if we have a dolphin in water and he's sort of jumping up, it's going to start off with kinetic energy, and as he makes his way to the loop, to the hole over here, all of it is going to convert into gravitational potential energy. Therefore, this is increasing, but this one is decreasing. So the gravitational potential energy increases, and the kinetic energy actually decreases. And we're going to write that as like so. And also, it's important that you do actually state this because it helps show your understanding of the question. So a lot of these questions sometimes require you to sort of create real life connections, and so it's important that you sort of state this. We're going to expand. And we're going to bring this to the other side. 1 over 2m. And actually, we don't need to find this. We need to find the resultant velocity. So we're going to rewrite that in a bracket as sine 40 resultant, the initial velocity squared. Now we have mass on both sides. Cancel those out. We have 9.8 gravity into 3.5. And we have 0.5 into sine 40 resultant velocity squared. So what is this on the left side over here? That is 34.3. And then if we divide by 0.5 on both sides, you should get 68.6. And then we can root both sides as well to get rid of this square. So we'll root both sides. And what that should leave you with is 8.2 sine 40 like this. And if we divide by sine 40 on both sides, I don't have space anymore, you should simply get the initial velocity that the dolphin launches itself as 12.88 meters per second. Remember, two significant digits. Therefore, the dolphin launches itself at 13 meters per second, 40 degrees above the horizontal. So that is how you solve a question like